Hi, I'm Vince. I'm one of the co-founders of Plastic Labs.
I'm Courtland, another co-founder, Plastic Glass.
And I'm Ben, the founding engineer. Plastic.
Great. And I will put that at the beginning. Yeah, so today we released a whole suite of eval performances, and Honcho has fully determined the Pareto Frontier. And what we mean by that is not only does it score state of the art across like three very important memory benchmarks, but it's also able to do so in the fastest, cheapest, most token efficient way. And we're sort of like defining the Pareto Frontier that way. And that will contextualize a whole lot of the conversation. All right. This is the tell-all podcast.
Confessions.
Confessions of
Yeah.
engineers in the
Yeah.
memory space.
Yeah. Yeah.
Oh, geez. Yeah. I wish I had more time to prepare sort of like a list of topics to like go through. But I mean,
I know, me too.
I think just at the top, obviously, like
Up with my eyes.
well, first off, like this is an amazing day. Coming out and just determining the Pareto Frontier.
Yeah.
Right.
Yeah. It's been exciting. And we've had some of these results for over a month now. So it hasn't been just all at once. It hasn't been a surprise, but I guess I could walk through the timeline of like what I've been coding this past month or two. Maybe start there.
Yeah, I think it's great.
So
Yeah.
we initially many months ago published a research post describing our neuromancer model and its performance on Locomo.
Right.
And that was state of the art.
Right.
It was like 86% on
Yeah.
Locomo.
Yeah.
And we have that post that's available. We link to that in our new post and everything. But that was the state of the art for Locomo. We didn't run any other tests, and we have been running a version of Honcho that more or less works like that in production ever since.
Mm.
And that was our first step towards state of the art.
Yeah.
And then recently, like over the past 2 months, really, I've been sort of introducing rigor in the form of Beam and Longman and making those part of our release pipeline along with other members of the team.
Right.
And we've been improving Honcho with results that we get on that. Because we started and we ran these tests and we were getting good scores, we were improving, but we saw room for improvement in the traces. And so we made changes to how Honcho ingests data and all this kind of stuff. We also introduced a new phase of the system that we've been planning for a long time. It's called dreaming.
Right.
That involves running background tasks over the representation of a peer in Honcho and then trying to improve it before any questions even get asked. Introducing that to the benchmarks made improvements on some of them. I didn't make improvements on others, and we published our configurations for each benchmark and, kind of different configurations within dreaming and then also dreaming on or off. And so we're still working on it. It's still very much a work in progress, but all those changes culminated in running all these benchmarks and getting top scores on all of them with the same version of Honcho too, which helps kind of show that it's a balanced system because these tests have different they ask different questions, they have different context sizes, and so Honcho can, one version of Honcho can handle all of that.
Right. Right. So, yeah, it's amazing. Courtland, when he was talking about that, it was just sort of making me reminisce on like the early days, like pre memory benchmarks, pre Pareto Frontier. Like when we started the company, we were talking about just how like agents needed some sort of mechanism to like maintain continuity of identity, to enable them to have a theory of mind about people. And when we would talk about that, people would be like, oh, so you mean like memory? And the whole time we were always like, just like, yeah, but it's more than that, right? And for a while, we sort of were like kind of going down our own path, trying to elicit theory of mind abilities from language models. But I mean, yeah, I think like the sort of like the origin story of us entering this side quest of trying to perform or trying to run the memory benchmarks all together, teed us up for what's now our Pareto dominant approach. So yeah, I'm curious, like, do you have any thoughts there?
Yeah, I know. I have a lot of thoughts. I mean, like, yeah, I think like early on, like in like 2023, right? Like, early plastic labs, like the most interesting questions to us, like the most interesting things were like, oh man, these psychology departments are like eliciting theory, like realizing that language models, um, you can elicit theory of mind abilities from language models, right? Like you can make you can draw conclusions and make predictions about what someone is thinking just by feeding, allowing the language model to metacognate on the conversation history. And that was like, holy shit, right? Like these things have like an emergent theory of mind. And so like, yeah, those were the most interesting questions to us. Like, ultimately, like in the beginning, we were trying to give like our AI tutor a state, right? Like we were trying to make it stateful, have it remember things about its users. And so, it just blew our minds that not only could it do that, but it could like cohere to their preference set really quickly. It could like form hypotheses about the identity of that person, and we found that created like really great experiences for end users. And so, yeah, I think like um, you know those have always been like the really interesting questions to us. I think it's like rather, and we talk about this all the time, it's like kind of unfortunate that we've all decided to call this like AI memory, right? Or the market has decided to call it that, right? Like it's so much more than that. It's not, like statefulness would have been fine, state would have been fine. I mean, theory of mind would have been fine, but I understand why it's not that. A lot of the things that we do still are theory of mind or help us determine a theory of mind about a user, but like, and I get that it's not identity modeling or all the things that we could call it, but it really is more than just like memory, right? Like we tend to think about memory because of the way it's been traditionally approached in software is like store and retrieve, right? And then like the subjective experience of having a memory as a person feels like store and retrieve. Like the phenomenology of that experience feels like I pull something out of my head, right? I retrieve it and then I remember. But really, like memory is like way more complicated than that, right? Really, what you're doing is like is uh, you're doing very much like what the model's doing. You're simulating statefulness, right? Like you have experiences and you encode that sensory data into a representation in your brain. We don't have to get into all the cog side there. Like not everyone agrees on what's going on there, and like we like to nerd out on prediction and surprisal and like you know generative cognitive science and all that. But like fundamentally, like really what you're doing is you're using that representation that you encoded and then you're simulating what the past was like, right? You're making predictions about what it was like to be in the past, and that's a simulation. Like it's the hallucination, right? Like it's an experience. It's more than just store and retrieve. It's like an active reconstruction. And really that's like models are doing the same thing, right? Like they're not stateful, so we have to create the illusion of statefulness. The way in which we do that is by building representations and then using that context to simulate statefulness, to make it appear that the model has learned about you over time, has retained things about you over time. And so, like, yeah, I mean, I could soapbox about like the space being called memory forever, but like, I think it does get to like, I think it does get to like really where we find like a lot of these evals and benchmarks failing, right? Because like um, like there's a lot of nuance here. Um, but because of all the, the stuff I just like waxed about, you know, there's a lot of things to measure in terms of like what a good memory system does to simulate state that I think we wish were prevalent in the these benchmarks, but just aren't, right? Like really what these benchmarks are measuring, like you talked about in the announcement video, Vince, is like that, they're measuring the efficacy of the context window. Um, and so that's not really measuring storage and retrieval, nor is it measuring like the more complex things we're doing in terms of like simulating state. Maybe you guys could go off on that for a little bit. But yeah.
Yeah. No, I felt like that was good historical context to add, and sort of how it tees up like this moment we're in with the sort of space race that's going on around like Longman Eval S in
Yeah, well,
particular, right? Like,
it's ridiculous. Unfortunately, it's today is Friday, and I think I'm just very happy to be putting this to bed
yeah,
because we've released our results, and one of the most interesting findings is that for reference, like like a longman s is the eval being referenced. It contains like 500 questions. Each question has about 115,000 tokens worth of context that needs to be properly managed in order to get the correct answer. This test, when it came out like a year ago, was, in the original paper, being run against GPT-4o and some other models that were fairly, frontier at the time. And they were scoring in the 50-60% range without any augmentation, without any RAG or anything like that. And that was considered sort of the baseline to improve upon with a memory system. Um, That was over a year ago. I mean, the Gemini 3 Pro is a recent model, just came out. You can run the Longman S benchmark against Gemini 3 Pro directly, just feeding the 115,000 tokens in and getting an answer, and it gets a 92% on the eval. So that's state of the art. That's the eval is no longer useful as a measure of memory at that point. And by the way, that last 8% are like questions that have semantic wordings, and the judge feels like your answer is not good enough. They're kind of silly answers that I as a human probably would not get right,
right,
according to the judge.
right, right, right.
The judge prompt is part of the eval, comes in the paper and everything. So yeah, it's over for Longman S. But this doesn't stop people from releasing scores in that same range, in that 90% range, and saying, oh, look, it's the new state of the art. And there've been all these little, ticky tack, 0.5% improvements that have claimed state of the art, which are all below Gemini 3 Pro's baseline. And some of those evals used Gemini 3 Pro, and some of them scored lower than baseline. And these are getting compared to evals that were run over a year ago. So it's not interesting anymore.
Imagine adding a cutting edge frontier model to your framework and it doing worse.
Well, this is the reality for a lot of things. Not to go on a tangent here, but Claude Code, every time there's a new model, people get excited.
Yeah.
And it's really good.
Yeah.
And then it falls apart.
Yeah.
Right. Something happens.
Right.
And then people freak out. They say, "Oh my God, is Anthropic quantizing the model? Are they cheating us out of tokens? What's going on?"
Right.
And it's actually just the harness. It's updates to the software that the agent is running inside, updates to the tool definitions, updates that they didn't even want to push. It's so easy to make a model perform worse by getting in its way.
Yeah.
And so it's actually not surprising at all to me that like there are people that are underperforming the baseline with a framework, because like you can really mess up a context window. It's easy to do. And that's still a real thing. Even a very, very intelligent model can be poisoned in the context window. Yeah. So not surprising. Now I'm happy that we don't do that. We ran Longman S with Honcho and we got a 92.6%. So, we're getting all the questions that Gemini baseline gets and a couple more, but it's like, it's silly. It's not useful information for anybody. Right. So we're kind of done with that benchmark. I don't think we'll be running it again, other than as part of our like continuous deployment pipeline, just to verify that the system is functional before we push it to our consumers.
Right.
Yeah. I mean, another thing to get into, which you kind of hinted at, is like that, at this level, right? This like 90, 92, 93, like, well, this is like the theoretical limit of the benchmark as well, right? Like games beyond that are like, could be the result of just like one, variance, natural variance from one generation to the next, right? Or like judge disagreements, prompting, like, it doesn't, it's like not only is it like, the silliness of using like a Gemini 3 Pro, you know, because like that's like not deployable in production. It's going to be like super expensive and like, and also like, it's doing at the theoretical limit, like without a framework in just, with the tokens in the benchmark, but like,
Yeah.
beyond that, like it's just not meaningful to talk about these like ticky tacky differences, right? Like,
Yeah.
Yeah.
Well, there's two big things that you just touched on.
Yeah.
So one is like cost efficiency, which is, I think, where these evals do still provide interesting results. And we have a whole section and a calculator in our evals page for this that you can check out. But basically the question becomes like, okay, let's run the eval on the baseline and see what does that cost. If you run, and we calculate this for all of the different tests. If you run like LongMemS with the Gemini 3 Pro, like it's $2 per million tokens of input. And output doesn't matter so much here because you're answering the same question either way. So the output's going to match whether you augment a model with a memory system or not. But the input is like $2 per million tokens. You do the whole eval and you're paying $100 or more for like ingestion. And that's fine for running an evaluation, but in production, if you're actually serving an agent that's getting a lot of use, that's a cost. That's going to be a primary cost for you as a builder. If you use a memory system, in theory, you should be able to drastically reduce that cost. And other people are not like publishing these things, and I don't know what the answers are for various different, pieces of software in that space. But I know it is for Honcho because we're considering that a big part of the eval. So we measure token efficiency, which I want to come up with a better name for because like the problem with the name right now is like the token efficiency lower is better. And that feels wrong.
No, yeah.
Token efficiency 100% means that every time you answer one of these questions, you're using 100% of the available tokens to create your answer.
Yeah.
So like for a long man question that's got 100,000 tokens, you're spending 100,000 tokens on ingestion, on input to a model to get the right answer. So that's 100%. That's bad because like then you're not doing anything with your memory framework. It's like useless. So we score on average with Honcho, like, the version that we use in production, all the model settings and stuff, is like 11% token efficiency on that size, those questions.
Right.
So for 100,000 tokens of context, we're spending like 11,000 tokens on input. So 90% cost savings, like very good. Like that's where even in a situation, and I think this is only going to continue to become the case as models will get better at utilizing their context windows. You're not going to get an advantage, a significant. I mean, there's there is evidence from our evals that we have a small advantage over even the top models in terms of reasoning within the context window, but the big advantage comes from saving money in that context window.
Right.
So that's the one thing that came up, Courtland. And then the next thing is the larger context, because models still top out at 1 million tokens of context. And there is like really significant drop off like in that million in terms of their ability to do recall. But we have evals now that are testing over 10 million tokens. So Beam is to me like the most interesting eval. Oh, you lowered my contrast.
You were getting a little blown out.
A little washed out.
Yeah, no.
Okay. Well,
Above it once. But yeah, sorry.
Well,
on the fly.
Courtland, like I do want to talk about like
let's talk about Beam,
Beam and like 10 million tokens of context, because that's where you still have a place where frontier models can't even be a baseline because they can't handle that many tokens, but Honcho can.
I mean, let's start there because I mean we already called out this space race that's happening around LongMemS. but that's silly because it's 115,000 tokens,
Yeah.
and that fits comfortably in like most frontier models, context windows. And like the next iteration of that is Beam. No one's talking about Beam, but it came out on Halloween. We identified it pretty early on, and we had we have a flexible harness. Like I found it because I decided to go check one day, and I was able to, like, on a Sunday, vibe code a script that made use of your harness, and it implemented it slightly wrong, but it ran, and we got a score. And that's awesome. I mean, like, but nobody talks about this one. So you spent some time with it. Would you sort of fly over what it is and
no, Beam is good. Beam is a good eval. I think it's the best of the evals that we ran. And I think it's the most, like, useful one today. But I also want to say that I don't think it'll remain useful.
Right, like all the others.
Problem.
Yeah.
It's in the same way that Longmem was an upgrade to Locomo in terms of size, like Beam is an upgrade. But anyway, there's 4 sizes, 100K, 500K, 1 million, and 10 million. And those refer to basically the amount of tokens that are used as context for answering the questions.
Right.
And we score very well compared to the baselines published in the paper. Very happy with the results. At 10 million, there's a definite drop off. We're scoring in the 0.6 range, like mid 0.6, and I'll describe how that gets judged. And then when it gets to 10 million, we drop off to about 0.4, which shows that, like, there's still major room for improvement in these, like, super long context environments, and that's kind of where we're going to continue to build.
Right.
But let me explain the scoring too, and then we can discuss. Beam, I think, has the most sophisticated LLM judge harness for any of these evals. Rather than a pass-fail, it actually assigns a grade based on a rubric. And the rubric is designed such that essentially you can get half credit, which is a pass, right? Like 50% is like a pass in one of these other systems. But then there's a whole nother set of points beyond that to get to the 1.0, to get to the 100% score, basically, that involve, like, semi-subjective measurements of, like, accuracy and confidence level and, detail. And I think that's really valuable. And it's started to give us, like, grades that we actually like for trying to measure what we're really trying to measure, which is, like, does Honcho give good answers?
Right.
Not just like, oh, does it recall? Does it understand the context?
Yeah.
Does it understand the context of a conversation that you had with your assistant a year ago?
Yeah.
And then you had 1,000 other conversations. And then you say, look, I'm going back to the subject matter that we've discussed before that I would assume you understand.
Yeah.
Because I gave you an understanding a year ago. And then there's a subjective judgment of, like, how well the assistant does it at that. And I like that a lot. So it's a good setup, and we're state of the art. So I definitely welcome challenges to that.
Yeah. Hopefully, this brings some attention to that benchmark.
Yeah.
And we get to, we'll see who reports on it.
Right.
But yeah, I think, like, the interesting observation from my perspective was, like, we're performing, like, on average twice as good as the RAG framework they reported in the paper, which, like, shows that, I think, obviously it's, like, still an unsolved problem, but, like, because we're able to ace all these other ones, or at least we're at the theoretical limit of all these other ones, and we're able to process, that much more token, token count, the approach, right? Like, the reasoning approach is sound, but the search problem is still, there's still a ton of improvement for that. But I think, like, the biggest point we're trying to make is that reasoning over the data creates a more tractable search base, right? And so now it's, like, just a question of improving the search. And, like, I think when you're limited to, like, a RAG framework that stores facts, right? Like, you're at the whims of what the LLM thinks is a, noteworthy fact worth storing. And as a result of this reasoning approach, you know, it's much more composable, it's modular, it can be dynamic. Conclusions can be scaffolded, sort of like on a query by query basis. Uh, it's just a much richer set of context, and we were talking a lot about the efficiency. And I mean, I understand what you're saying about like sort of like the semantics around efficiency, like thinking about how I was saying in the announcement video, and I was like, I don't know, I feel like most people would get that if you said we're using 11% of whatever, it's should be okay. But I agree, we could probably do better. Um, I think the like oh, I lost my train of thought. What was I talking about before that?
Um, I don't know. What were you talking about?
Just like the reasoning being like a better approach. Really, like
Well, I think,
Yeah.
I think that like the thing you're trying to get at is that RAG alone. You were talking
oh
about
right
you were
right right
talking about RAG in the Beam paper and how our approach does a lot better, and how RAG alone has these problems of yeah, the LLM. It's up to the whims of the LLM
yeah
to figure out like what you're actually looking for. That's why we started doing so much better over the past couple months. Is like we totally re-architected how we answer questions and also how we reason over basically conclusions that we draw from the initial message.
right
So we draw explicit conclusions from the initial message, and then we have a background task called a dream that reasons over those explicit conclusions and looks for deductions and areas to consolidate
right
and contradictions and all of these things that are like pretty effectively judged by Beam.
yeah
This just happens to be like a methodology that aligns with like what they're looking to test,
yep
which is nice. I just think it's correct in terms of memory.
yep
But then there is still like, I think there's still gaps. And it's kind of like, I think it's also the point where groups doing memory, as you mentioned, Courtland, like groups doing memory are doing very different things at this point. We've like had speciation. Like there are
Yeah.
still definitely projects that are like focused on like we're just gonna make like perfect RAG. Like this RAG is gonna be really good, and we're gonna tune it, and we're gonna get you guys good results on like a benchmark that measures recall. And we're like not doing that at all at this point. Um, but we're still using semantic search and embeddings in a way that's actually way more like RAG than it is like what some other companies are doing for memory. So you're right that the term memory is like completely overused at this point. Um, Both OpenAI and Anthropic have memory in their assistants in Claude and in ChatGPT. They have these memory systems which basically like do this kind of like summarization and like vignette formation process that's kind of like a tool in the loop of some of these agents, which is a cool approach. But we're like, I don't think that is what we're going for at all. I think that that approach is like lossy on purpose. It's kind of designed to be not great. It's like, you know, they know what they're doing. They don't want to do memory. They want to do
Yeah.
like something else that I wouldn't call memory, you know?
Yeah, no, I agree. It's really interesting to see like we were talking about this the other day. You look at like how they're doing memory, and it's like yeah, it doesn't seem that they like have any drive or desire to really do it or do it well, right? And like, and there might be all kinds of reasons for this. I think there is predominant feeling within these labs that like like scaling will continue to pay dividends, right? And maybe a shoddy system that didn't work very well now will work better later, or that the context windows will get better. Um, you know, I think both of those, like, one, you could debate like scaling progress, but like um I you know I think that like one, like that's we're seeing like scaling, scaling like start to return uh, more poorly in terms of capabilities. But we're also seeing like even if context windows get better, right? Like there's still all kinds of problems with like how you engineer the context window. What's the ideal form to put context into the window? Like how do you manage that? How do you manage it from session to session? You're always also going to go beyond like like if we were talking about relationships with agents over really long term, right? You're starting to get into, like very large millions of tokens, right? And so there's all that. I think there's also like the optical kind of thing. I mean, I think when you look at the prompts for like memory, like I think in Anthropos prompts, like I remember there was something about like not remembering certain types of personal details are like not nice things about users, right? Like there's like deliberate sabotage of the memory. So there's like concerns around like optics and like um, what they want these general systems to be used for and what they want them to be like capable for. So yeah, I mean it's like it's kind of a mess. But maybe it's worth talking about like our like high level approach in terms of like how we differentiate, because I think like that illuminates things. Like essentially, like Honcho as a system expressly does not want to take opinions on like the data that comes in, right? Like the data that goes into a peer's representation, right? Like we want to capture what we call all latent information, right? So like all information that is contained in a message, whatever kind of data the message is. So to begin with, you have to like articulate everything that is like explicitly in a particular message, right? That's like every proposition contained in something a user said or some data about a user. Um, every single statement that could have like just one truth value. We want to atomize all of that. And then we want to use that to scaffold, arguments to do further reasoning, to reach conclusions that can only be reached by thinking about that articulation of data. Um, and so like, it's hard to predict like what you'll reach there, right? Like you have to actually just do the reasoning to find out. But basically, like you could consider that latent information in a message that can only be unlocked via reasoning and this exhaustive like articulation. And so Honcho's goal is to capture all latent information, because we don't know what an application or an agent, what context they're going to find useful, what context they're going to need moment to moment. It's our job to ensure that if it is possible to arrive at a piece of context from information written to Honcho, that we have arrived at it and that it is available if an agent or an application needs it down the road, whenever that is. Um, we also might arrive at interesting conclusions based on data that came in 2 years ago and data that came in, combining that with data that just came in and doing that reasoning. And so it's really important to like build a representation that captures as much of this latent information as possible. And then like opinions are the job of the agent or the application, right? We use the example all the time. Like if Honcho learns something not so nice about you, um, which like Anthropics is instructing the model not specifically not to retain. Like Honcho doesn't take an opinion about that, right? But your AI therapist might decide that it does need to take an opinion about that to like maybe help you overcome that not so nice thing about your identity. So um, yeah, I think this is just a very different approach, fundamentally different from what the big labs are doing. It's also fundamentally different than what a lot of like um, other memory solutions are doing. So like not only is like the technical approach different, but like also we'll see people, if they are doing any kind of like fact extraction, they've defined some kind of taxonomy based on, some part of cognitive science that they feel is important, right? They say like, we're going to divide into like episodic and semantic and associative types of memory. And we're going to store based on those. And we're going to specifically look for like just those things that we can categorize into those boxes according to this taxonomy. The problem is like that leads you to miss a lot of latent information, right? And that relies on your taxonomy being like extremely robust and inclusive. And we just find in practice that those just aren't. And really, those taxonomies in cognitive science, those are just meant to help humans understand different types of memory, right? They don't describe how memory is actually created, you know? So when you use the taxonomy, which is meant to help you categorize memory, to create the memory, that leads to all kinds of like downstream problems. I mean, and like the major thing is that you miss a lot of context. Um, like the human brain really is trying to capture uh, as much latent information as it can based on like prediction surprisal mechanisms. But it also cuts a ton of corners because it's trying to maximize energy, and it's operating in an information and like energy constrained environment and had to evolve that way. And so all that to say, we can do better than biology. We can have superhuman memory. We can extract all latent information. We can do better than these other approaches by not taking um, opinions that lead to like loss of context. And if we do all of that, and we have sufficiently articulated like the latent space of context, then um, like the memory should be better, right? There's more in there. It's more articulated. Um, we have a richer set of conclusions to draw from. Um, and so, like, the upshot is you should perform better on a memory benchmark, or what we might, evals that we might create later that are like more suitable to memory systems and not just context windows. But it was a big ramble. But I think it's important to understand, like, foundationally, the approach is different.
No, that's great. Yeah, I mean, the first thing that I thought of when you were talking about all of that was like, there is so much opportunity to build really interesting products as a result of this. Like you're talking about the difference that like AI therapist would take on top of some data than like Claude would, right? Like uh there's like a ton of opportunity for like essentially like baking in expertise to a language model by using Honcho context to build a really robust data set of hyper personalized, hyper specific examples that like increase, they bias the distribution of responses towards things that might be much more relevant to your use case. I'm thinking like the therapist is one example. Like this applies in almost like every domain, right? Like finance, fitness, health, any sort. I mean, this kind of makes me think of your example, Courtland. Like a while back, he would talk about sort of like Honcho getting to know you as well as your spouse, where like Honcho would like be able to advise you in different areas of your life that like it's not necessarily an expert in, but because it's such a good reasoner and it like knows you across all of these different contexts, that it's like able to provide useful advice. And now like not to compare it to like a spouse or something, like it's like a substitute, but in the same way, right? Like taking this approach of sort of exhaustively reasoning over data coming into Honcho and using this like formal logic, this type of reasoning that humans are awful at, right? It's very intensive cognitively for us to do this. It's like, well, we can always continue to sort of like push the envelope on how small, fast, cheap, and effective the language models are that do this to create so much sort of like overhang between what you could do and throw the entire sort of like corpus of context you have on somebody into like the next 10 million token premium frontier reasoning model. Or you can use a hyper specialized like logical reasoner through a general system like Honcho to cut down on that overhead and do it at like a fraction of the cost. And so like this sort of gets into like our bigger pitch, but it's like if people start to adopt this approach and like start building super bespoke, like contextualized data sets in their verticals, then like ideally an application or an ecosystem using Honcho would cover like a broader surface area of use cases and go deeper on any single one of them than any incumbent could with their walled garden. And like Lord knows what OpenAI and Meta and Anthropic and Google are all doing with our chats.
Yeah.
So I wanted to throw that out there. There was another point I thought of as well, but I'll get back to it.
I like what you're saying about cost, and it is funny, Courtland, that you mentioned like how humans operate at a frontier of yes, intelligence, but also energy efficiency. There's a analogy that's been drawn many times before with that and token usage, and we are actually kind of shooting for a similar optimum, right? um, it can't just be about recall, because one, that models will continue to scale in that way. I think, that is subjective, but I think they will. And then, but more importantly, is recall alone is not that useful actually, and it's not similar enough to how humans remember things that we're going to get good outcomes if we're using agents as human like things to perform human like roles and jobs. Um, what I mean by that is like perfect recall across all the tokens you've ever processed is so far from how human brains work that it's going to appear really smart in some ways, like a search engine appears really smart, and it's still going to be an idiot in other ways, like synthesizing across instances and doing like Bayesian priors updating across instances of a subject being referenced by a fellow agent or human. um, and so it does come down to like basically reasoning over memory and reasoning in the background and all this stuff that we've been basically implementing. um, yes, but
Yeah.
cost is also very important because in order to sorry, this is another topic, but this is something that has been like a problem for us, I think, when it comes to like getting people to even understand or care about agent memory. Because what happens is that people are in practice deeply concerned about cost, to the point where I think they're being ridiculous sometimes. Like there are people using models that came out 2 years ago to do things that they should really be using the latest models on, but they're sort of like stubbornly sensitive to cost, and they're like, I'll never spend that much on inference, that kind of person that we meet all the time. um but first of all, they should be spending more on inference, but if they're cost sensitive, they're also scared of like spending money on memory, you know? And people make that worse because they're using these really token efficient, inefficient memory setups, and they're using these models that are, I'm too smart to be doing memory in some ways. And so like it's just muddying the waters. It's actually making it harder for the whole space to be, thought of by certain builders as useful. That was a jumble, but you guys know what I'm talking
Oh, yeah.
about. Please help me make that
Oh, yeah.
clear.
No, yeah, no, totally. I think it's like, yeah, I think it's a huge problem. I think you're right that like people should be spending more on inference. Um, but yeah, that cost sensitivity does create like a lot of like detrimental behavior, right? Like, yeah, I'm not going to spend on memory. So I'm going to have this like kind of naive approach. I'm going to like try to shove a bunch of stuff into a context window. The only way I can get that to work is to use like like latest model, right? Um, and but none of this has been reasoned over, right? None of this has been organized in a way to like optimize the context window so that it can actually make sense of these things. Um, and yeah, and so that creates like this leads to like real problems with like adoption and retention and churn in AI applications, right? And a lack
All
of
kinds of
trust.
products. Yeah,
Yeah,
yeah.
Right.
And people in their attempts to save money are spending more money because instead of using something that does reasoning in the background, they are using more tokens in any given query. So I
yes,
really like the calculator on our evals page because I like showing people this saves you money. Like
yeah,
it,
yeah, and it
it saves
works,
you a lot
and
of
it
money.
works better. Like the
Yeah.
token efficiency isn't just about saving money too. It's about like having the optimal tokens injected in the context window at any given time. Like it's kind of counterintuitive to think that like um actually like doing the reasoning is going to save you money, right? It's like, oh, I'm going to do like extra reasoning over my context. That to me sounds like that's going to cost me more money, right? Like I'm spending more on even more on inference, and that's problematic. But really, like when you do that up front, we can do that really fast, really cheap. We do that up front. Then the context has been like, like the latent context has been captured. There's more of it, right? It's higher quality. It's organized in such a way that when you do that retrieval and when you put the context, you put the context at any given turn into the agent's context window, it's optimized, right? Like there's less of it, but it's all more potent and it's all more relevant. So like there's less of it, so it costs you less, but it's also attended to better because it's exactly the context that you need. You're not just shoving a ton of tokens in there, um, and hoping that that the model like understands, catches the vibe, or finds the important context like at inference time. It's like really risky for UX, and like it's really reckless in terms of spending, right? Because to like get performance there, like you said, you have to use a better model. Um, and Yeah, so you're right. There's like this paradigm shift needs to occur, right? Around like how we think about memory and how we think about spending here. And actually, it's much more economical to like do reasoning on the front end. Um, yeah, to make sure that you can effectively manage that window and use faster, more effective models as well.
Well, that's another thing I wanted to talk about is like you mentioned muddying the waters, and you mentioned just getting clear about what memory is. It's like this is I spent so much time kind of like trying to tease out like solid definitions for what like memory is and what it means to remember. And like we talk a lot about identity, and that's sort of like influenced by your cog sci philosophy background, but like that until recently that hadn't had like a really solid definition with us either. And like memory as a word, right, exists at like different sort of levels of abstraction. Like I was talking about this with Leonie. He's like for folks unfamiliar, as a writer, been writing a lot about agent memory on her blog. It's like memory exists as like a singular, like atomic thing. It's like this was the definition we sort of agreed on. We were like, when we think of memory, it's like, oh, it's a core memory. Like that was something from like my childhood that like really struck me to my core.
A vignette. Right? A vignette, yeah.
A vignette, right.
That's the word we use in code.
Yeah. So like it exists on like an atomic level, but like you can also talk about memory as like a system. It's like this sort of collection of capabilities that work together to create this like this illusion of recall, or like it's just sort of like this catch-all term for memory. And like remembering is the act of like employing that system or like constructing those atomic things. And like my god, I was sort of like all over the place. And then like one day, Courtland, you were like, really like memory isn't actually a thing the way that people talk about it. Like it is this just like colloquial catch-all term to sort of like describe this capabilities, this experience that we have. And like for the longest time we had been talking about memory being like a reasoning task, but like gosh, just sort of like being able to like dispense with the word memory and talk about it purely, especially like on our docs. If you go to our docs, like right now it's under like version 2.6.0 alpha, but like soon it should be merged to main and it'll be like on the homepage of the docs. But like we explicitly talk about it in service of simulating statefulness, and that is like the clearest way to like sort of describe it. Simulating statefulness is done by injecting reasoned tokens like into the context window. We have a number of different methods that allow you to do that. And like it's like some of these frameworks have just sort of been like built around the term memory, and like they're trying to draw these like faux distinctions around like the difference between like memory and RAG and like memory and all these different things. They're calling memories different things in their code base, and it's just like the waters are already muddy. It's just like someone needs to cut through and talk about what you actually have to do here. And I hope that we've made a dent there.
No, I think so. Yeah it's really interesting. There's also like so many different ways that you can architect an agent. Makes it more complicated as well. So on top of everything that you've just described in sort of like the memory system, that what you could call a memory system, you have different modes of interacting with the memory system from an agent. I had that little diagram I drew that's been my cornerstone for this. But you have like, okay, one I would call like agent with memory, which is like you have an agent and like you have like some tools. Maybe it can like save files to a file store, and then it can like retrieve those files later. That's memory, right?
Yeah.
If the agent wants to remember something, and you probably have to prompt it very specifically in order to get it to exhibit this behavior, you're like,
Right.
hey, if there's something that you think is important, you should save that to
Yeah.
your file system, right?
Yeah.
And then, if you're answering a question that seems like there might be some interesting relevant data, and this is the hard part, by the way, is like, go check the file system, right? Go check there. Like that's memory.
Yeah.
And then
Yeah.
there's like, you know, uh, that's like agent with memory, and then there's like agent that has memory grafted onto it. This one's kind of like I feel the most negatively about this one because it's basically like I think it's like doing a Frankenstein thing to models in the same way that like
Yeah.
people criticize the system prompts that get like tacked on to ChatGPT or similar systems. You read these system prompts and it's like, 15,000 words on like what you can and cannot do. And people have been very explicit about this on Twitter. I love when people describe it this way. It's like you are basically like lobotomizing this being with all these rules. Imagine if every time you opened your mouth to talk, some voice from above blasted down at you 15,000 words on what you can and cannot say.
Mhm.
It would stop you. It would stop you
Mhm.
from behaving in an intelligent fashion. So like there's like a form of memory that does this, where like instead of like providing interesting information, it just sort of like grafts data onto a system prompt.
Puts the smiley on the Shoggoth.
Yeah.
Yeah.
So it's like pre-injected,
Yeah.
So I prefer agentic,
Right. Right. Which is the third one, to be clear. Yeah.
Well,
Or-
agent with memory is agentic.
Okay,
You have
yeah.
tools that give you access. But here's the problem with that one. And here's the third one. The problem with the giving it tools is that pollutes its space, right?
Right.
If you're a coding agent, your tools should be about coding.
Yeah.
If you're a browsing agent, your tools should be about browsing with a web browser. A memory agent should be its own agent, and that's the architecture we have with Honcho. Honcho is a memory agent, so instead of agent with memory, it's agent that has access to another agent that manages memory. It's dedicated to the task.
Mhm.
So it's a multi-agent system. When you use Honcho in your agent, you're setting up a multi-agent system. Your agent is fully responsible for its own work and its own role, and it has access to Honcho as a memory management service. And it can reach out and ask questions and communicate in natural language, so there's no tool burden. And then it can also ask for context, and you can build your agent loop such that data automatically gets saved to Honcho, and that's how you do ingestion. So this is kind of like the best of both worlds. You get good recall. You get like basically we can update our tools as models evolve. And your agent, like whatever you're building, doesn't have to like worry about that. It just uses what it knows to interact with this agent.
Yeah.
So still fleshing that out, but we should like write another blog post all about that.
Yeah.
Someday.
Yeah, Courtland, when he's talking about all those different sort of like compartmentalizations of like tools and access due to like that agent's role, it makes me think a lot about what you would talk about around sort of just like the way language models work, right? Language models being simulators. There exists like optimal identities for different tasks. I mean, I think, yeah, like you want to talk about that just a little bit more.
Yeah, I mean, I think this has been well like understood for a while, but especially like early days, like kind of like the LM psychologist space or whatever. But yeah, I mean, but I think this has been like shown in rigorous research that like different agents adopting different identities perform, the same underlying model, right? Perform, wildly differently at a task, right? Some are better and some are worse. And so, yeah, I think that squares pretty nicely with like with thinking about these things as a multi-agent system, right? Where one agent is responsible for one particular task, and you can figure out like what the optimal, not only what like the optimal way to build that, but also like the optimal identity that you want that agent to assume. Yeah, for sure.
Yeah, I think it was a paper out of NVIDIA when they were like for very early days of DS Pi. They ran like some of the optimizers on a couple of math data sets, and they analyzed the system prompts. And like one of the system prompts that saw like a significant delta on like math reasoning benchmarks had like Star Trek like in the system prompts, and it's just very interesting
Yeah,
to
yeah,
think about sort of like those tokens
Yeah.
sort of like shifting the distribution of like, you know, uh, token probabilities towards um, something that samples better for math reasoning tests.
Yeah.
Like what the hell?
Yeah.
That's
yeah, yeah,
wild.
yeah. You tell it to act like Spock, or yeah, it does better.
Right.
Yeah, it's interesting. I mean, it makes you think. There's a huge space to investigate too when we're thinking about like taking um, taking identity data from a peer, which is really what it is, right? Like the peer is, is um, in Honcho is like for any entity that you're trying to understand, right? Like something that's different at time t and t plus one, but is
Thank
like
you.
the same thing,
We needed
right?
to define
Identity.
that. I said that.
Um, yeah, you're trying to model the identity of the peer, right? That peer could be a user, it could be an agent, an NPC, a group, or like whatever. You can use, we love to see more use cases of people using peers in interesting ways in Honcho, but yeah. So you think about like that is identity data, right? It's like what we know about the peer, right? And Honcho is like selecting what we think to be the optimal context for the moment to deliver to the agent, um, like to do whatever it's trying to do. But yeah, like that context has an impact, right? Like I think more than people typically realize, like the way in which you structure that context, the form in which you deliver it, how you deliver it, it's all like dramatically important to like the generation that you get, in your app or agent, and therefore like the UX that gets delivered to the user. So like there's a huge space to like to explore here.
Yeah.
This is why like I think, and this is back to like what I talked about at the top, like these questions have always been some of the most interesting to us, right? Like sure, like we're doing memory, but we're also like, if we're trying to create the most robust peer representation through this like formal reasoning, extract all latent information, like we're modeling identity here, right? Like, and that is like that's a big ambitious goal, to try to model identity with as much fidelity as possible, right? To try to get your representation to approach the actual complexity of the real identity it's based on, right? Maybe eventually asymptotically approach the real complexity of that identity. um that creates like all kinds of, I think, AI app and agent use cases that um people haven't even begun to think about, right? You have that rich of a reservoir um in the representation for each peer, then like you know you can start to do really much more interesting things. Right now, we don't tend to trust models to go out and execute tasks on our behalf very much, right? Like we want to be very much in the loop, right? And we all run up against, as we use AI tools, like all kinds of failures. We have all kinds of like prompting strategies and workflows that we've built to like mitigate the fact that they can't be as autonomous as we would like them to be. Um, and really to be that autonomous, they have to have like a really rich sense of who you are, right? If they're really going to anticipate your needs and really go out and complete tasks in the way that you would do them or better, so sufficient that you trust them to just do that without asking, or to even intuit your preferences and then go do those things, like they have to have really rich representations of you, of who you are. And so like you know these are like the longer problems that we're interested in, and why, and part of why we take such an exhaustive approach to creating context and building representations through this like formal reasoning process. Like, I mean, the upside of that short term is like great, it performs great on like memory evals, right? And we can have great token efficiency, and like you know will set us up to perform well when we actually have good evals for memory systems themselves. But like long term, it's this stuff, right? It's like it should also allow us to like build all kinds of new, interesting, autonomous agent experiences. Finally get maybe past this like skeuomorphic phase of AI where we're just like, you know, you know, yeah, take this thing that already exists and make it AI, right? Turn it into a chatbot. It's like the .com era, right? Like pet stores exist, let's make pets.com, right? Like financial advisors exist, let's make AI financial advisor. Like, I mean, those things are exciting, But like really we want to get past that stage, right? We want like unbounded intelligence that can be a real extension of our cognition and our identity and can like go out and do stuff for us in like delightful ways that we didn't imagine. Like I think, the the kinds of representations we're trying to build are like a key primitive here for all that.
Well said.
Yeah, very well put. Um, yeah, I guess that kind of gets to the conclusion of these evals, which is that they're cool, but we need to build much better ones to get at what we're trying to get at, and that's going to happen kind of naturally over the process of fine tuning training models to solve these reasoning tasks in Honcho, which we're doing.
Yeah, I was gonna say that'll be the next big sort of like lay it all out there podcast. Is just like the entire sort of like ML workflow that we've been sort of cooking on internally. You know, these people don't even know who you guys.
Next podcast we'll have you, and next podcast we'll be announcing new benchmarks, but new scores on new benchmarks. I would say
right.
And that's exciting.
Right. Yeah.
I think we're done with these benchmarks for in terms of using them as a ruler for Honcho. You know, Honcho is not a memory system, so it's not really that interesting.
The iteration's been really lightning fast on sort of like the reasoning eval side of things, and we've been seeing some really interesting progress. And, I mean, it's sort of like the sky's the limit there. Like this, sort of take a step back, right? Like this, we talk about this too sometimes, just like this is what justifies taking a lab approach to this problem, right? Like, plenty of people could have sort of started a company and like made a couple of tool calls.
So if I could register a prediction regarding that whole like agent distinction that I was making earlier, I think that with the way things are going in coding models, which are, I think, definitely the state of the art in terms of like what can a model do. I think coding models are basically AGI in the domain of coding. They still stumble, but in ways that humans stumble. They're not ASI, but they're AGI.
Yeah.
But that's not the prediction. The prediction is that recall will be a solved problem by models with tools. Like tool calling and reasoning in a model is getting so good, and I see this with Gemini 3 Pro in particular, that like there's really no question of like, do you need a memory system for pure recall? Because the ability of an agent to call tools that do that kind of stuff, and their ability to like use those tools is going to just reach saturation.
Right.
So in order to build, so that's part one of the prediction. Part two is that alone is still not enough to do all of these things that you've been describing, Courtland, in terms of social intelligence and job capability, basically.
And trust.
Yeah, trust. Yeah. Saying,
autonomy.
Hey, agent, you can do this for me. I trust you. Like that pure recall will not fix that.
Yeah.
So then part three is like you need this kind of like background reasoning, Honcho style, in order to get to that level. So that's the whole thing.
Love it.
Yeah. Totally. We need gotta get building evals. I mean, Beam, I'm still interested to see improvement on Beam. That's the only one that I think
that's true.
That's
true.
But beyond that,
yeah. It'll be interesting to see kind of like, there is an element of subjectivity to it, right? Like, are you satisfying how the question was phrased, and like the judge involved, and I don't want to overfit too much to that because we want to be sort of like this neutral system, but like almost like we talked about this when it first came out. It was like, because of that setup, there were some categories that sort of seemed like we should have another LLM that takes in Honcho context and is prompted specifically to answer like in a certain type of way, and like maybe we like, I don't know. That's honestly, you could probably DS Pi that Like you could optimize that prompt against the judges' scores, and we could sort of run an interesting study that analyzes the prompts that take the Honcho context and score the highest based on different judges.
Yeah, but like as you said just a second ago, overfitting is a
Exactly.
problem,
Right.
And
Right. Yeah.
And
Need another agent in there.
yeah. And so like what I'm like thinking, all this talk of like job performance from a model
Oh yeah.
gets me to this position, and also sort of like an agent using Honcho agent.
Yeah.
Like that's sort of the ideal architecture in my mind.
Yeah.
So maybe the ideal like eval is like it's not ML continuous learning, but it's continuous learning in the form of performance review, where this agent is mostly interfacing with other agents, and those agents are prompted to rate it and judge its effectiveness.
Right.
And basically, it's this large scale, like in computers it's A/B testing, in humans it's performance review. It's this like merge of the two behaviors where like the Honcho agent is constantly receiving feedback.
Yeah.
Of like, are you doing a good job?
Yeah.
And not are you doing a good job on recall? It's like, are you doing a good job in the world?
Yeah.
Are you getting things done?
Right. Well, so actually this gives us an opportunity to talk about something I don't think has been explicitly stated but implied by Courtland, is that like in order to do that well, not only does the agent need some mechanism to like maintain continuity over its own identity and time over time, it needs a way to sort of like maintain state on the task it's performing. Like I'm sure as it goes on and gets feedback, like the nature of the task would change a little bit. You might call it the same thing, but the nature of the task would change. The nature of its manager giving the performance review, it needs a robust sort of model or representation of its superior, right?
In the same way that a person does.
Yeah, exactly, right. And it needs a model of the environment so we can sort of interpret the feedback it's getting from it, right? So like this is sort of the flexibility of Honcho as a framework. It's like, because we're taking this general approach, it's formal logical reasoning over any input data that comes into the system. You can model not only an agent or a user, you can model a group of agents, you can model a task, you can model an environment. Like all of these things sort of fall under the umbrella of identity modeling, which requires rich reasoning and like kind of sort of speaks exactly why like we think Honcho goes much further beyond memory and why we're kind of done with these benchmarks. So I think that'd be a really interesting thing. It was making me think about GDP val, right? GDP val is a big thing. Like I think their new GPT 5.2 models took like a 40% jump on that benchmark. It's like went from 30% to like 70. And I was thinking about like what you were saying in the performance review context and being like, you need GDP val, but like for individual workers, like you're modeling like Helly from Severance.
Yeah.
You know what I mean? Like I was like, it's like Agent Village, but like Severance Village, but like each of the agents has like its own unique identity and it's like own unique task and own unique manager, and like it's not just like this speaks to the problem with a benchmark like GDP val. It assumes that there is like one way to do the job that's like globally accepted. It's like just not true at all, and like probably is one of the like main contributing sort of explanations as to why like AI hasn't been adopted as universally as everyone expects it to be. Right? There's just so much variance individually. That's just why there's another huge thing we've just like identified very early on from the beginning of the company. We were like, oh yeah, like that is a huge unsolved problem. People are not talking about that.
And this is why we joke in the office about we're not selling Honcho to like humans, we're selling it to agents.
Yeah.
Because like
yes,
you go down this like conclusion and you realize that like agents are employees like any other, and sometimes they need to purchase software products to improve their productivity.
Right.
Like how we use Notion or Gmail.
Yeah.
It's like
superhuman.
I need superhuman agent, please. I need a better memory solution.
Right.
That's kind of the conclusion of all this. and that's what it's going to look like. And evals are going to look like that. It's going to be GDP bench, and like, does the agent with this memory augmentation strategy perform better on GDP bench? Not, oh, does it recall this? Does it recall that? So it's holistic for sure.
Right.
Yeah.
What would you add? That was your territory.
No, I mean, I totally agree. I mean, I think eventually the customers are agents for sure. And like, yeah, like I need a system for continuously learning about my users or about this particular task or whatever, right? And like, I'm going to use Honcho to do that, and use Pierce to do that, and create representations of these things, and like, yeah,
Yep.
No, totally. I think that's I think that's the future. We talked about where the tipping point is with this the other day. I feel like, it has to do with something, like agents having, like purchasing power, right? Like sufficient autonomy to do that. But like, yeah, I think it goes bananas like after some tipping point there, right? And really, like for a lot of people in the AI space, like your customers become agents as opposed to humans. Yeah.
Yep.
It's very exciting.
It is.
Yeah.
It is.
And yeah, what a great way to end the year.
Yeah.
What about agents needing to model other agents, right? Like if there's trillions of agents, they need a system to like form representations of the motives of other agents, right? Like,
Right.
I mean, that's massive, right?
Right.
In a competitive landscape in like any field, right? Where, you have lots of other agents basically in this like dark forest of an agentic economy, right? And I need to figure out what their motivations are. Like I need to like understand, I need to a way, a system for understanding all of them, right? Like that's
Yeah. I do think it's so interesting how, as you mentioned earlier, giving an instruction in a prompt, even now with these just ludicrously intelligent models like Gemini Pro or Opus 4.5, of a phrase or a sentence or a tool within that prompt can dramatically change the kind of generations you get, whether it's the difference between a good looking front end or an ugly one, or an essay that reads like slop or an essay that reads like pretty decent, it's all prompting. And Claude skills, or like, skills as a concept, are like really embracing this. And we're already seeing like, an evolution beyond like, oh, we're all going to be using skills now. But that's actually why the agent that provides memory is so important, because if you just try to graft memory onto an agent, you are polluting the context window. And that's maybe it makes your generations better in some cases, but in other cases they are going to get worse. And it's much better to have like a clean room approach to the context window whenever possible. That's what I've learned, building Honcho and also using it. So I'm very in favor of that and providing that as a service.
Yeah, totally. And I think high level, you're right. Like the intelligence of frontier models at this point is stunning, right? Like the capability overhang is massive, right? And everybody's sort of been like banking on just like more scaling, right, to like solve every problem that we see, right? We'll see how that landscape turns out. I think we're starting to see diminishing returns to scaling, but like now it's like really time to figure out like what are the overhung abilities, right? Like what systems can you build around this like raw intelligence, right? What tools can you give them, right? Like what other agents can you give them access to, that can like really explore like the breadth of possibility here, because like it is crazy unexplored. I mean, like 2 years ago, we were talking about, like overhung abilities being dramatically underexplored. And, when we were talking about 3 years ago, like GPT-3, like, now like, I mean, these things are incredibly more intelligent, right? And like we still haven't begun to build like, yeah, the systems around them, the access to other agents, the harnesses, that whatever, like to, to really see like what they can do. So yeah.
Well,
Yeah.
I just, I almost completely agree. The one thing I would say is like scaling could actually continue
Totally.
at
Sure.
quite a massive clip. But I still agree with you on everything else because that doesn't change the fact that the form factor of the scaling is into a version of intelligence which is incredibly sensitive to its context window. And that's not going to change. So
Right.
context window management, broadly speaking, will, I think, always be a thing as long as LLMs have context windows.
Yeah.
There could be architectural changes which obviate that, but we're also looking at that, right? I mean, we're thinking super long term about, instead of doing user modeling in token space, you do it in weight space and so on. So like, we're open to that.
Yeah. Yeah. Totally. Totally.
Yeah. But Honcho works now, so
Sure.
now,
Yeah.
in the here and now, we're
Yeah.
very happy.
Solves problems and saves money now.
Yeah.
And with that, if you would like to try Honcho, sign up, get an API key at app.honcho.dev. If you would like to try out a stateful assistant built with Honcho, that you will have to talk to get anything, any sort of transactions run for you.
Yeah.
Fun fact is it's powered by X402. You can buy things on a marketplace, and it's inaccessible to humans. You have to talk to the agent. The agent will have to do that for you.
We're experimenting.
We're really trying to push the edge there, right? We talked a lot about autonomy, so we're putting our money where our mouth is. There, Honcho.chat is where you can find that, and yeah,
evals.honcho.dev to dig into everything we covered today.
yes. Check out evals.honcho.dev.
Yeah.
All of them can be replicated for quite a low cost. So
Reasonably low cost,
Yeah.
Yep.
Yeah.
Yeah.
You got $100 free credits when you sign up. Honcho. Put those to use replicating evals if you want. And if you want us to top off your credits because we'll do a bunch running evals, then let us know. Happy to do
Yeah. Yeah, if you find this interesting, please get in touch. Today was kind of a big sort of where we put our head down, we work, and then we come out with big announcements. And then we put our head down and work again. So hopefully these pieces of content make the rounds, and we expand our network and meet some really interesting people thinking about these problems. So shout out to the team too. We have an awesome team at Plastic, crushing. Yeah, super grateful.